Hello everyone, welcome to another episode of Multisim. Today we are going to be looking at troubleshooting resistive parallel circuit in Multisim. Multisim has different kinds of components, but here we will specifically examine a component called rated components. These are components that you can specify the ratings so that when they are exceeded, you will see some visual animated effects like blowing up. As we can see in the diagram, we have 5 resistors connected in parallel with a DC interactive voltage ranging from 0 to 50 volts. Then I installed an ammeter to measure the total current in the circuit. Each branch has an ammeter and also a watt meter to measure the power dissipation in each resistor. So let's move to the next slide. You can see the question. A certain parallel circuit consists of 5 half-watt resistors with the following values: 1.8, 2.2, 3.3, 3.9, and 4.7. As you slowly increase the voltage across the parallel circuit, the total current slowly increases. Yes. Suddenly, the total current drops to a lower value. A. Excluding a power failure, what happened? What is the maximum voltage that you should have applied? Specifically, what must be done to repair the fault? I love this. So we are going to demonstrate it in Multisim and see how we can answer these questions. Alright, we are in the Multisim environment. As you can see, I've drawn the circuit. This is this interactive volts which I got from under sources. You can see it's DC interactive voltage. Then the rest resistors under basic. You see rated. You can see rated. I selected this rated for each resistor. Then our ground, this one down, you get you go to power sources and you select ground. You can see the ground. Then the ammeter, this ammeter here, we can select from place indicator. Under it you see voltmeter, we see ammeter, we see probe, we see lights, and so on. So that is it. Then I just arranged them and connected them. Then these are specialized probes. You can see this one is A. They wrote A. This amps, to measure amps. Then you see W, watts. You can see them up here. When you click on this current, you can see you can place it like this. But since I've placed them, there's no need for that. I will escape. I think that is all we need. Then here we have the key. As if you double click, you can see I set the minimum to 0, maximum to be 50. Then the key is what I'll be pressing for it to be incrementing, and it will be incremented by 2%. So that's it. So now for us to run the circuit, we'll click on this run button, or you press your F5 button. When you press F5, first of all, let me set it to 0. Now it's running. You can see it's red. Now it's running. So let's see something. Now I'm pressing my A. You can see 1 volt has come. I've applied 1 volt. You can see the power ratings. So let me increase it to like 10 volts. I want you to observe something. The resistor of the least value has the higher current. You can see this 1.8 kilo ohms. You can see the current is 5.56 amps, milliamps, sorry. 2.2 kilo ohms has a lesser current. 3.3 has a lesser current. 3.9 lesser, and 4.7 the the least current. You can see that current is directly proportional, is inversely proportional to resistance in Ohm's law. That means higher current, lesser resistance, higher resistance, lesser current. Now let's go to the power. We can see the other one, 1.8, is going up, is going down, is going down, is going down. So the highest power, you can see it. The other power dissipation drops as resistance increases. Lesser resistance, more power is drawn. Now I'm going to reset it to 0 now. It's already in 0, sorry. So let me be increasing it from 0, 1. Be looking at the meter. You can see 2 volts, 3 volts. You see it's increasing. The power is increasing, and this is also increasing. The total current is increasing. As you are moving up, the total current is going up too. It's going up. Remember, there was something I did not show you. When you double click on the resistor value, I set each one to 0.5 watts. You can see it, 0.5. Each one has that watt. So that's the maximum it has. So I'm still increasing it. It's not up to 0.5 watts now. You can see 4.405. Did you see now? At 30 volts, that's the maximum it should go. This resistor has exceeded, R1 has exceeded, has reached its maximum rating. If I dare increase this voltage now, you will see it will blow up. And once it blow up, the total current will reduce, because now this place has become an open circuit. It has become an open circuit. Resistance has gone up. So watch this now. Let me increase it to 31. Watch. It blow. Do you see it has blown up? You see the current has dropped from 50 something to 38 now. You can see the power has gone to picowatts, while others are still intact. If I increase again, once anyone reaches that 500, this one will blow up now. It's going to blow up. It has blown up. You can see this is in nanowatt. As I increase again, the next one that will blow up is this. Watch now. It's going to blow up. Wow. You can see 1.6 nanowatts. And all these ones has even blown. Remember this one. This one, as I increase it, once it reaches 500, be watching, or exceed 500, it will blow up now. Watch. Watch, it has blown up. You can see. So, and you can see the total current has dropped to microamps now, because all of them are open circuits. So we can see that the wattage of the resistor 0.5. Once it gets to the maximum current and you exceed it, it blows up. Blowing up, that means for us to repair it, since it's this R1 that's burnt, we can increase the watts to maybe 1 watt, so it will last more, or we adjust the resistance value so that it will not reach the maximum current it's supposed to carry. So this is how we simulate or troubleshoot. You can see how the components blow up. If I say stop now and I reset this to 0, you see these openings here, all these openings here. When I say run, it will come back to normal now. It has been restored. But as we increase the voltages, once it gets to that 30, it must blow up. You see, this will blow up. You see, two has even blown up at the same time. So that's how the rated components work.